call in a few.
This meeting is being recorded.
And it is. So if you're not comfortable with getting recorded, you can feel free to leave. So hi everyone, welcome to another episode of ElixirKenya webinars. We're very excited for this one because Peter is one of us and has been one of us for like the longest time. So a brief introduction about Peter. So he has a bachelor's in psychology and a master in software engineering. Wow. He's from Germany, but lives in the Netherlands now because of the bike lanes, if that's a thing. All right, that's a good reason for someone to migrate, but it's okay. He likes sports and powerlifting and running and music. His kind of music is metal, rock, and he also plays the drums. This is a really interesting guy, and I'd really love to hear what he has in store for us today. So since we're 6 minutes into time, I'll just feel free to welcome you, Peter.
Thank you so much, Getty.
You're welcome.
Well, Jumbo, everybody. Nice to see you all again. Hello, hello. Okay, I'm just going to share my screen and then we can get started.
All right.
I'm going to put you there. All right, so if you cannot see my slides, please shout.
All right, we can see them.
Perfect. All right, well, so yeah, I would like to talk a bit about testing of your Elixir application. And let's just get started with the question, why should you test at all? Because, you know, we are software engineers, most of us, I guess, and you know, maybe we're you know, sometimes it feels like we are paid for features that we build, and well, tests aren't quite really features the end user or the stakeholders can see. So it's always a little bit hard to push for better tests and more testing, and to justify why we spend time on tests at all. So I would like to answer the question, why should you test at all? And you might think that it is about code correctness, so that you write your test to test the piece of code you have just written. And, you know, let's say you have like data transformation and you test it, and, you know, you just check whether what you have written does the thing you actually intend to do. You know, that's what you might think. And it is technically correct, but that's not the biggest point of testing. What's actually much more important is that over time, you develop stability in your system. And you can ensure a better stability of your system by using tests. And that's why, let's say you have a system and you update, you add a feature to it. Well, you might break some other parts of the system because of your new feature. And that's a problem, because you might only see that when you deploy to production, your production server crashes because of that error, and, you know, you lose your stability and your availability, basically. So yeah, that's one of the reasons why tests are important, to make your system much more stable over time. And that is to prevent crashes, basically. But then you also have like soft crashes or errors, basically. And you don't crash the entire system, but, you know, you throw an error, something doesn't happen. The customer or the user is unsatisfied with your system because they click a button and nothing happens, for example. So it's also about quality assurance you're testing. So you can assure that you always have a certain level of quality that you offer to the user and to the stakeholders. Then a big part for us as developers is the collaboration between us. And that's the same thing when I change a piece of code that my colleague, for example, touched, and I break it, I might not know about it unless I run the tests again. Because my ex-colleague, or my colleague, he or she might have a certain idea in mind why that person wrote the code, and I change it and I break it, but I don't know that I broke it. So tests are also a way to communicate with others, with our colleagues. And like communication is a big keyword here, because sometimes, and you know, I also do that sometimes, that I write code that nobody understands but me. And even I don't understand it all the time. So if you write a test for that, you can actually show your colleague and yourself in the future how to use that piece of code, how to use that service, and what the inputs are, what the outputs are, and so on. So it's also about communication. And the last one is testing is a time saver for yourself, because if you don't write automated tests, then you might have to click yourself or click through the website or your system yourself, or test the API manually, and that takes a lot of time. Eventually, if you don't test, you will also have more bugs. So you also need to debug much more, spend much more time on that. And that will kill your sanity. And eventually you will give up and just leave the company. So it's also a sanity savior, testing. So I hope you understand now why it's important to test, to write tests. And your next question about that might be, well, we understand that we have to test. But now the question is, how do you, or which tests should I write? And for that, there is a nice diagram that is called the testing pyramid. And the testing pyramid, as you can see here, it is a pyramid. And at the bottom, you have the majority of your tests. And those are your unit tests. So your very small tests that only test a single part of your code, like called units. On the left, you can see the scale. So unit tests are very fast, especially in Elixir, where you have multi or concurrency, where you can run multiple tests in parallel. So they're really fast to run, but they only test a very small part of your code. So they're very isolated. And you also create like a perfect test setup for them, where everything is exactly as it needs to be. And then you run your test and it might fail or it might succeed. So those are like the foundation of your entire testing framework. And if you build on top of that, if you go to like a larger scale, basically, you go into component testing. And that is still just on a code level. You have a setup, you create some values in your database. And instead of just calling one single function, for example, like, update a particular model, you might call like one service or one handler that calls, again, multiple different parts of your system. So imagine you have like a handler, and that handler fetches something from the database, it updates it, or it gives it to another model to be updated, and then it logs something or it returns a certain response. So in that particular piece of code, you actually call 3 other parts of your system. And if you test these kind of bigger services, these bigger parts of your system, they might be called component. So that's why it's called component testing. And yeah, the more you go higher in this pyramid, the broader the scope of the test becomes. Unfortunately, also the slower mostly the test becomes. So if you run a component test, it will take slightly longer, and it might not be able to be run in parallel with other tests because it touches so many different parts of your code. So that's why it's a bit slower. Then if we move again one step up to the integration tests, well, if you will ask 10 different engineers or 10 different testing people about what an integration test is, you will get 10 different opinions on what an integration test is. My definition of this is that you test your system from one end to the other. So sometimes they're also called end-to-end tests. But again, if you ask a QA person, they will slap your hand if you say integration tests are equal to end-to-end tests. Because an integration test could also just focus on your backend and not at all look at your front end. But if you want to have an end-to-end test, you really test from like your front end, from the UI, all the way back to the database. So the entire stack. But with an integration test, you can also single out certain parts. So only the back end, only the front end. But again, if you write integration tests, the scope of them is much bigger. So they might test your entire back end, but they're also much slower to run because you have to set up much more. It just takes longer to execute your call. But they have a better scope, so they test more. And then at the second last scale or step, so to say, you have UI and API testing. So UI testing, straightforward. You check you actually only use your UI, so only your website or your app to test your entire system. And if you go to that level of tests, like UI, API testing, but also already with integration testing, you go away from the small isolated tests more towards integration. But that also means that you rather go away from like functional testing, where you only call a single function and check that that is correct, more towards behavioral tests. So you test that your system behaves in a certain way. And that might be something like, when a customer makes a purchase in your shop, and or they put something in their checkout cart, and then they check out that cart, so they pay for it. That might be like one test. And eventually you need to understand, you want to test that your system takes that purchase, schedules, for example, the delivery, updates the availability of that product in your database. It might send out an email to that customer. It might notify your fulfillment service, for example. So like that, that's like one big behavior, basically, where just by clicking that checkout button and paying, you trigger so many behaviors or so many after processes of your system. So that if you go high up in the pyramid, the more and more you will rather test behaviors of your system, which is more like abstract level. Right, and well, the very last step and the smallest step of the pyramid is the manual and exploratory testing. That is really a person, a QI tester, a developer, or even your user, your end user. All of them, they perform manual tests basically on your system. So whenever your user clicks that button to do something, that's kind of a test, like does the system still work, yes or no? So yeah, those are the manual tests. Those are the slowest tests that take the longest. They're also the most time intensive and tedious tests to do. So that's why in these pyramid of tests, they have the smallest step. So you should try to minimize the amount of these tests because they take much time and money in that case. All right, so that is the testing pyramid. And yeah, so the question was like, which tests to write? So if you look at the pyramid, as I explained, you will have a very broad foundation. So many tests that are focused on single units, so unit testing. And then slowly and less so, you will write bigger, larger tests. So you have a lot unit tests and you have very few UI tests, for example. And yeah, these are the tests you can consider writing. Okay, so now that you understood and heard about the testing pyramid, let's ask the next question. And that would be, how should we test? And for that, we have different concepts. And they are called the black box, the gray box, and the white box testing. So the question is, how should you write your test? So the question is also, what should you assume? What should you use? Which tools should you use to write your test? So should you directly look into the database when a user, for example, checked out? And should you check directly in the database that the availability of the product was changed? Or should you rather use your UI, like for example, the admin or salesperson UI, to test that change actually happened? So if you rather go to the side where you say, I look at the system as if it is a black box. So I have no clue what's in there. I have no clue, which language it's written even. I don't care about that. All I see is a website where I have certain buttons and products, for example, and I can check out and I can buy stuff. And I have my email client and I receive emails there and so on. So that's more like a black box approach. So you don't assume that you have any knowledge about the internals of the system. All you see is like the UI and a button, and you have your browser. And you can use that approach to write tests. And you would rather use or write UI and API tests like that, and you would do a manual and exploratory test also with that. if you have ever done a security audit by a security researcher or information security specialist, you will also ask about, they will also ask about like black box testing, gray box testing, and white box testing. And the important thing is here, let's say you have an information security person and you ask them to audit your system, like to check the security of your system. If you ask them to do a black box testing, they will only try to hack, so to say, your system through what they can see as a user. So there will be the UI, there will be your API, and that's about it. And any endpoints you show to the user. So they don't know anything about what's actually happening in the background. And yeah, so this way, it's like the black box testing is a good way to look at your system and forget about the technology and only care about the behavior of your system, to test the behavior and also use what you're seeing. Yeah, so long story short, it's rather UI API testing and manual testing that you use for black box, or like you use black box testing for these tests. Then you have gray box testing, in which case you assume certain internals, that you know about certain internals. So for example, it might already be that you know that if you have like a front end, let's say you have a React front end through which the user interacts with your system. And in black box testing, you would only have that website and you don't know whether it's React or whatever. In gray box testing, you would understand that you have a front end and it might be React. And you also have a backend that offers an API. So in gray box testing, you would also use, for example, the API directly, like communicate directly with it and check it this way. And you might also understand that you have an email provider, like an email client that sends emails for you. So you actually can like check their system, ask their API about whether they send any emails or not. Yeah. All right. So yeah, that you would use for more like manual testing and automated testing. Both tests you can do with that. You can write an automated test to test for testing the API, but you can also manually click or use the backend, for example. Yeah. And then the last concept, so to say, is the white box testing. And in white box testing, you have full understanding of the internals. You understand that there's a database, you can access the database in your tests, you understand that there's an email client, you can call, like check that an email was sent. You can call any function in your code, like you have an understanding of your code architecture and of your just code. So that's more white box testing. You're full, well, the tests that I explained, they would use white box testing, but a white box test can also be, you still test through the website, through the UI, but you understand that you click a React button and the React button executes a certain function and then calls the API, and the API calls a certain service that calls the database. So although you still test through the website, you have an understanding of all the different functions and concepts, technologies that are underneath your button clicks, for example. Yeah, in this way, well, you know, the scale of black box to white box testing exists because you might change your tests depending on what you know about the system. So when you know that there is an API and you know that there is a service that gets called by the API, you might actually think about the service when you write your test for the API. So you send certain parameters to the API that gets sent to the service, and the service might crash because of the parameters you're sending. So this way, if you have white box testing, you can test something inside the box from outside the box. So you know something is inside the box, but you test through the website, for example. Yeah. Anyways, enough about the theoretical concepts of everything. Let me show you a couple of like example tests here. So for example, for black box testing, you can use something like Cypress. I just added a very simple Cypress code fragment here, like one test. And it uses the Phoenix Live View like temperature thing, where you click a button and you just change the temperature in your UI. And the Cypress test, like if you use black box testing with that, it only uses your website. It only uses a button that is in your website. So you visit your website. You can even write a test against your real domain. So you don't need to just run it locally. You can also run it against your actual server. It visits the website. It checks that the HTML it's seeing, that the browser is displaying it's 25 degrees, or like your thermostat is set to 25 degrees. And then it finds a button and it clicks it. That's everything it does. And then it checks again, is the temperature that the browser shows me is at 26 degrees now, right? So this is really high level testing, really like UI testing, you know, black box testing. You don't know anything about databases, or you don't care about the stack, whatever. You just care about the info you see, you care about the interaction, and you care about the update info. Yeah. All right, so that's black box testing, an example for it. Then let's have a look at the gray box testing. With gray box, I used Phoenix LiveView here, the Phoenix LiveView test framework. And it checks in this case that you can't set a temperature to above 30 degrees Celsius. And it does that by navigating to that particular website. But it's like, this is an automated test. Like, you don't even start a browser or nothing. It's just, it uses the rendered HTML. And yeah, it goes to the website. It looks for a certain form on the website where, for example, you can type in the temperature you want, and it submits that form with a certain set, with a certain map data set here. Yeah. Yeah, sorry, so I just have to sit down a little bit. I feel a little bit woozy, but luckily I can do that while you think about gray box testing. Yeah. Okay, that's much better. All right. Okay, that's much better. All right, so about the gray box testing, you understand that, you know, here you don't use the browser. You already use the HTML that your browser should render. So you don't use the actual browser. You use like just the HTML that you receive back. You also have some knowledge about the internals. So you know that there's an element that is a form. It's not just your browser that shows you like a little input box. No, you understand that there's a form. And you understand that there's a parameter in your form that is called DEG for degree. So, you know, like this DEG variable here, that's already a lot of knowledge you have about how your website looks like and how it behaves. You know, because if you just type in the number in your browser, you don't care about whether it's a form or like an input field. You don't know what the actual parameter is that gets sent to the backend. You just care about the input field. But if you have this render submit form here, you know there's a DEG parameter, so you already have some understanding. Yeah, so that's gray box testing. And then the last one is white box testing. An example for this is we have full access to everything in the entire system. In this case, it's a rather simple white box test. It just like has a payment. You create a payment in the database. You set it up with a factory. You set it to a certain status. So you already know that, you know, a payment has a certain status field, and you know that that status is currently pending. Yeah. And then you call, you know, a service, and you mark the payment as paid. And, you know that there's a service, you know that that's a function, and you know that you have to enter that particular struct into this service. And then you check that the service actually updated the status. So it set the status to paid. And again, here you access the repo directly. You use the get call, the payment struct, and so on. So you know everything about the system. And that basically is white box testing. Yeah. All right. It just, you know, I put the pyramid here because as I said initially, you can use white box testing and have like manual tests, right? You can have a manual test, but use white box. You can also write a unit test and have a black box concept. You know, if you just call a function and you see what it gives you back, and you don't care about anything that happens in that function. So yeah, it's not that you only use white boxing in unit tests and only black boxing in manual tests. It can also be anywhere. Yeah. All right, so with that said about the black versus gray versus white box testing, let's ask us a last question: how to structure your tests. And so the structure, and I'm just talking about the structure of a single test and not about like how should you set up your CI, your continuous integration pipeline for testing. I'm just talking, how do you write a single test? And there is a method for that, or like a philosophy, which is called given, when, then. And it's pretty simple to understand, I would say. It's just you have three scenarios, so three statements. So let's have a look at this test here. It's about updating the age of a person. And currently that person has an age of 18 and we want to update it to 19, right? And we want to check everything. So the given, when, then statement, it first has the first step, which is called given. And well, in this case, given we have a person in our database with a certain ID that has an age of 18, right? So that's our like baseline, our initial statement. Now, the next step is the when statement. And it basically asks the question, well, given we have the person, when we update that person using the person's context, the update function, and we input like a age 19 parameter here, right? So that's our when statement, like when we execute this. Then we assume, or we test that that person was actually updated in the database and has a new age of 19, right? So that's a very basic structure for your test. So it's a nice, you can put it in a sentence, like given we have a person of age 18, when we update that person with a new age, then the person has the new age of 19, for example. Yeah, so you can write your tickets like that if you wanted to. You can write your test like that. Yeah. Right. So one last thing about the given step. Most of the time you leave that out because you assume that your factory does it for you. So when you insert the person with age 18 here, that is basically your given step. I would say not always need to do this given step here, like check that the person's actually in the database because you just inserted it. It depends on the test, because sometimes you insert like lots of different structs and you really want to check, like, I call my function here and it returns me an error. Then I, for example, like you create something, right? Like, first it's not there. So you call for it and you get an error back, it's not there. Then you create that thing and, when you create that thing, then it is created and you get actually a struct back here, right? So that's something you can do on a higher level. And then it makes sense to write a given step as well. Yeah. Sorry, I kind of rushed through it. That's already the end. So I think we have still time for questions and so on. So please shoot.
Nice. Thank you, Peter. That was a good session.
Thank you so much.
And sweet. Yeah. So if anyone has any questions, let me just check on Slido if there's any. One sec. All right, so we have 2 questions on Slido, and if anyone feels they have a question that's burning, if you just feel free to unmute and ask. One asks, let me start with the latest one. Black box testing, is this similar to what quality assurance does in a project development setup?
Yeah. Well, yes and no. As I explained with my attempt to give an example of an information security specialist. So the QA person, they might or might not have an understanding of your system. And well, most of the time they do have an understanding of your system. So they do white box testing. But again, as I said, like white box testing can also happen with manual tests or UI tests, for example. So they might understand it. Yeah, as I said, when you do a security audit for your system, you can choose different levels. You know, you can say, I want to have a security audit, but on a black box level, so to say. So I, don't want to give you any information, only check this URL, that's our system, go for it. So you can do that. But most of the times, if you want to have a more complete test, then you do white box testing. That takes longer because the specialists, they need to understand your system, they need to read your code, understand your architecture. But eventually they will find many more like small things inside your system that might lead to a hack or like a security problem or just a bug or or just a crash, for example. So yeah, it's not one-to-one correlated. But with QA testing, if you do it in-house, it's mostly white box testing, or at least gray box testing, because they mostly have an understanding of your system. Yeah, I hope that answered your questions.
Oh yeah, makes sense. I hope that answers the question. Thank you, Peter. The next question would be, is it safe to say that white box testing is for developers?
Yeah.
You have to understand the internals and stuff.
Yes, well, most of the time it is what you do. Mostly you do white box testing. But just think about the situation where you get the code from your colleague and you don't fully understand it and you have to write a test for it. Or you have to, then it's kind of like gray box testing because you understand your architecture, but you don't understand that particular part of the code. Yeah, so it's not always white box testing, even for developers.
All right, got it. Thank you. We have two more questions. How do you automate API testing? It's an interesting one.
Yeah, well, API testing, I know that there's some frameworks for it where you, I think even Postman can do it nowadays. So maybe you heard about Postman, which is like a little software where you can send HTTP requests to your server. They have an automated system now where you can just run different requests. But API testing, yeah, it depends. Like, do you want to do it outside your system or within your system? So when you want to do it outside your system, you would have your API backend running on a certain server or in like a Docker container. And then you would have a second, let's say, Docker container or a second server that actually really like pings or like sends HTTP requests to that backend server and tests it, right? And yeah, that would be like API testing from outside, so to say, where you have like two different servers and one of them is testing the other one. And that's, for example, what this Postman framework does, and there are other systems where you can do it. But maybe you want to do it like inside your system. So then you can just write like a Phoenix test for that, Phoenix controller test, for example. Yeah, where you simulate an HTTP call to your Phoenix controller and check what the result is and so on. And that will be API testing as well. Yeah.
All right. Thank you, Peter. Makes sense. Our other question would be how to go about testing if a project is constrained for time.
Yes, that's a good question. So some people say that writing tests actually saves you time, even if you're constrained on time, because you will do less debugging. So yeah, if you skip your tests while writing code, you will spend more time manually debugging and testing a system. And if you write the test from the get-go, from the beginning, you actually save the time eventually. So yeah, I can understand when you have like a hackathon, like a 2-day thing, sure, then don't write any tests, just go for it. But if you do more than a week or maybe at max like 2 weeks of coding, then you should have written the tests really, because you need it. It also ensures that your system actually, still works. Like because you write so quickly, you develop so quickly, you might break one part of your system while you create another one, and you don't know about it. And then after 2 weeks, the deadline is there you deploy and the customer is angry because that part of the system doesn't work. Yeah, and just the last word, some people say that if you do test-driven development, it's called TDD, test-driven development, then, which is basically you write your test first and then you write your function, your functionality. If you do that, you also will save time eventually, because you write the test first, so you understand better what you actually want to write next. Like you get a better understanding of your function. Then like you write a test where you say, I give this input, I get that output. And then you actually write your test and you fill that in, so to say. So that is also a time saver, because I mean, if we are honest to ourselves, how often did we like create a new function and then actually wondered, well, what do I actually want with this? Like, you know, what are my inputs? What should I return? What do I in between? Right. And if you do if you write a test first, then you already think about these kind of things. And then once you write the code, it's just like, bam, you dump it and you're done. Right. Hope that answers your questions.
Sure. Makes sense. I think one of my friends calls it developer-driven testing. This is when you do your code and do all your shenanigans and then write the tests afterwards.
Exactly.
So
yeah.
it's allowed. So maybe the questions keep coming in. So maybe two more, if you don't
Yeah, sure.
mind.
I've got the time.
All right. So what properties make white testing ideal for parallelization? I didn't know I'd ace that word, but there it goes.
What parameters? Yeah. So you can only parallelize your tests if you, if you can abstract the dependencies of those. Like, let's say you have two functions calling your database, right? You can have like two transactions and run them in parallel and roll them back in parallel. So yeah, that's like for unit tests, you can do that. So I would say, again, like white box testing is not equal to unit testing. You know, it can also be manual testing. So there is no parameter for white box testing. Well, okay, if you really ask the question, the only thing I can think of is if you understand the system, which you do when you do white box testing, you might be able to write parallel tests because you know how the system works. And then you just decide, you know, I'm going to write my test this way, because in that way I can actually parallelize it and have like multiple tests running at the same time. Yeah, but most of the time is rather like parallelization. You can rather do, the more isolated your tests are, which unit tests are the best example, and then component and maybe integration tests as the second one. Yeah, I don't know. I hope that answered your question.
I hope so too, but that was a really, really good explanation.
Thank you.
All right, so maybe one last one, Peter.
Sure.
Any book that you would recommend, I guess, around testing, maybe?
Yeah, there is a book about Elixir testing. I forgot the name, but I think it's called, like something like Test Your Application. Just look for Elixir book testing, you will find one. That is quite interesting. It also looks at X units and, you know, how it actually works under the hood and so on. I unfortunately can't recommend any books that look beyond that. It's just my experience.
All right. Is the book by Pragmatic Programmers?
Yes, like all of them
all
are.
Right.
Yeah.
Clearly. Okay. Thank you so much, Peter. This was a really, really good session. Does anyone have any questions?
Das Problem ist tatsächlich, eine Freundin von mir heiratet.
Benjamin, do you have a question or just muted by mistake?
In Schladming, in Österreich.
I don't think they have a question.
All right. Okay, so thank you guys. We still have some time. Do you have anything to say? Maybe I could give some few seconds.
I do have something to say. Well, I visited you in September and I promised you to come back, and I will fulfill that promise now in March. I will come to Kenya in March. Yeah.
Karibu sana. No, I guess you know
thank
that.
You. Santa sana. Yeah, I'm coming on the 5th of March, and I first go to Watamu again, to the beach. And then I come to Kisumu around, I think, the 14th, 15th of March, so mid-March. And I will be happy to visit,
really happy to
see you all again.
yes, I hope this time we can have like a combined meetup for everyone in Nairobi and Kisumu.
Yeah, sure. I mean,
Yeah,
I
we
would come. That would be lovely to meet everybody in Kisumu. But if you're in Nairobi, I will also come to Nairobi at the second part of that week. So around the 19th or so.
awesome. Guys, book your appointments with early enough.
Yes, I'm looking forward
All
to
right.
it. Yeah.
Thank you, Peter. Thank you so much. It was such a good session. I don't think I'm the only one who can attest to this. I think people have really had fun learning about, Chantel called it colors of boxes for testing, which is so
Yeah.
great.
Well, it's black and white, so, but yeah, those are colors too.
Sure, it's allowed, Chantel. So thank you
Exactly.
guys. You guys have a great weekend, and we'll see you on the next webinar. If you need to reach out to Peter, maybe you can post your Twitter handle on the chat.
Yeah, so this is my Twitter handle. It's PJ Ullrich, Ullrich. Otherwise, you can also go to peterullrich.com. That's my website.
Sure, I can attest that he's not a snob, so he will reply to your DMs.
Yes.
Okay, thank you guys. Have a good one. Bye.
Thank you all so much. See you soon. Bye-bye.
Thank you, Peter. Bye.